Okay, so Thomas is going to give a presentation on the introduction and basically talk about the binary cycle and whatever. We used these maps from the U of A report, which were depth and isopac and porosity maps. We were overlaying these in order to find the best locations that we could consider for drilling our wells. We found 4 locations, which are shown here. We chose the closest one because we didn't want to lose too much energy when we would transfer the electricity from the plant to Hinton, and we also wanted to be close to a river so that we could use that as a potential water source. Then here we've got 5 locations for the potential drilling sites, and then we chose the bottommost location because it was the most logged and easily accessible, and it looked very flat. Here we also use the depth and the isopac maps in order to help dimensionalize our reservoir, and then on the right we've got a casing size selection chart which we use to choose our casing sizes. We use the thickest ones because we were considering the longevity of the wells, but thinner ones could be used in order to make the cost less. Other drilling calculations were done by the drilling engineer, or were left to the drilling engineer to consider. For the downhole design, we considered an injection and production well, and then on the right there's a simplified design of the reservoir geometry. For the downhole pressure calculations, here's a top-down view of the breakdown of the different pressures, and then on the right we can see basically across the reservoir we use Darcy's law, and then for the injection and production horizontal sections we use the simplification of Bernoulli's equation where we only consider the pressure friction term. Then for the downhole energy calculation, we found the overall heat transfer coefficient. We've got a sample calculation for one of the thermal resistances, which is for water, but we also consider for the cement, the piping, and the reservoir rock. Then for the we use these to find the heat gained and lost in the injection and production wells. And then for the across the reservoir, we just consider the amount of energy needed to heat the injected fluid from the injection temperature to the final reservoir temperature.